Hey guys, welcome to part 2 of our lesson about graphing and solving inequalities, quadratic inequalities. So today we're going to focus on solving quadratic inequalities by graphing. So we're given this inequality here, x squared plus 2x minus 8 is less than 0, and we want to solve this by graphing. So remember when we talked about zeros and roots of our graph, to where if you solved for x, that's where your graph runs through the x-axis. Well, we can do that in this case. We can solve for x. We can solve this quadratic equation and find where the graph passes through the x-axis. So there are different methods that we use to solve quadratic equations. We did factoring, we did quadratic formula, we did completing the square. You can solve it even just by graphing. Any of those methods will work. So choose whichever is best for you. In this case, factoring it would probably be the fastest. But like I said, if you want to use a quadratic formula or if you want to complete the square to solve this, by all means, use those. But in this case, we can factor this x squared plus 2x minus 8. And if we do that, we would get x minus 2 and x plus 4. Okay, and if we are going to solve for x, we just set each one equal to 0. So we're going to set this equal to 0 and solve for x, and this equal to 0 and solve for x. So if we do that, we're going to get x equals 2 and x equals negative 4. So we said these are our roots or our zeros of our graph. So this is where it's going to run through the x-axis. So if we come and we graph that, we said it's going to run through where x equals 2. But looking at our equation, it says that it is less than, right, not equal to. So we don't want to include those points in our inequality. So we want to put circles where those are at. So where x equals 2, we'd put a circle right here. And then where x equals negative 4, we'd also put a little circle right here because we don't want to include those values in our inequality, right? So looking at our original equation, we know that this graph is going to open up. So in this case, it's not really necessary for us to find the exact vertex because we're just trying to find values of x that make this statement true when we're solving. So we want to find what values of x for this equation will make the whole equation less than 0. So we can just kind of sketch a plot of our graph, right? It's going to look something like that. We know that it opens up. We don't have to know what the exact vertex is. So what we now want to do is figure out where along this x-axis right here is our original equation true. So we will need to test a point that is going to be less than negative 4 to find out if any of these values make the statement true. We need to test a point that's in between negative 4 and 2 to see if it makes it true. And we need to test a point that's outside of 2 to see if it's true. So we're going to have 3 test points. Any point along here is fine. We need one from here, and we need one from here. So let's test different points. So let's start with just the origin. The origin is inside of here, correct? So the origin's right here. We can test this point and see if it makes our inequality true. So if we come back here, and we can erase this now, we want to set x equal to 0 and see if that makes it true. So if we set x equal to 0, you'll have 0 squared plus 2 times 0 minus 8 is less than 0. So you're going to get negative 8 is less than 0. And this is true, right? So now we know, looking at our graph, all of the values inside from here to here, all of these values in here make the statement true because we tested this point. So now we need to test the points outside. So we need to test these points and we need to test these points. So let's try that out. So this right here is negative 4. So if we test point, let's see, negative 6, let's say. Let's try negative 6. So let's erase this. So if we set x equal to negative 6, negative 6, change it back to black here. We substitute that in. So negative 6 squared plus 2 times negative 6 minus 8. Negative 6 squared, 36, minus 12, minus 8. 36 minus 12 minus 8 gives us 16. And this is supposed to be, let's undo that, it's supposed to be less than, right? Less than 0, less than 0, less than 0. Is 16 less than 0? No, that is not true. So we know that these points out here are not included in our inequality. These values of x are not included in our inequality. So now we just need to test over here. So we choose a point, let's say maybe 5, right? Because we tested, this is 2. So if we test 5, like over here, we can determine if this inequality is true or not. So let's come back here, erase this. We are going to test point 5. We're going to set x equal to 5. So we have 5 squared plus 2 times 5 minus 8 is less than 0. So that's 25 plus 10 minus 8 is less than 0. 27 less than 0, which is not true. 27 is not less than 0. So now we know that these values on this side do not make this statement true. So we just have these values in here that did make the statement true. So we just have this line that we drew with the open circles right here. And this is our answer. So if you're looking at this and you want to know what that means, it means these values inside from negative 4 to 2, so we can write that, right? We can say the values from negative 4, so x has to be greater than negative 4 and less than 2. That is our answer for this problem. Let's try one more. Let's see. If we are given the problem, let's see, negative x squared plus 3x plus 10 is less than or equal to 0. So we want to go ahead and solve this quadratic. And like I said, you can use the quadratic formula, you can use factoring or completing the square. In this case, it would be very easy to factor. If you factored it, you get negative x plus 5 and x plus 2. Like I said, if this way doesn't work for you, use the quadratic formula. That's fine. But to solve for x, we need to set each of these equal to 0. So when we do that, we get x equals 5 and x equals negative 2. So this is where our parabola is going to pass through the x-axis. It's going to pass through at negative 2 and it's going to pass through at 5. And these points are going to be included in our inequality because it says less than or equal to. So we're going to put dots instead of circles on our graph. So if we come to, let's see, our graph, let's put a background here. And let's plot these points. Okay. We said 5 and negative 2. So 1, 2, 3, 4, 5. And we're going to put dots. And negative 2, we're going to try to put a dot for the letters. Okay. So we know that our graph opens down, right? Because the a term is negative because this term right here is negative. So our graph is going to open down. And it's not really necessary for us to know the vertex. We can just kind of sketch a picture, right? So it's going to look something like this. So we need to find which values of x make our statement true. So we need to test a point that is less than negative 2, in between negative 2 and 5, and greater than 5. Figure out which points on here make the inequality true. So let's start out. We can test point, let's say 1. 1 is right here. We can test that point. It's within negative 2 and 5. We can see if that makes the statement true. So let's see. Let's erase this. So if we set, let me draw this again. So if we set x equal to 1, and we substitute that back in, we're going to have negative 1 squared plus 3 times 1 plus 10 is less than or equal to 0. So if we do that, we get negative 1 plus 3 plus 10, which is 12. Is 12 less than or equal to 0? No, it is not, right? So we are not going to include these values in our inequality. So now we need to test a point out on this side. So if we test, let's say, negative 6 or negative 3, even negative 3 is right next to negative 2. We can try that point. So let's come back here. I'm going to erase this. And let's set x equal to negative 3. So in this case, we're going to have a negative 3 squared plus 3 times negative 3 plus 10 is less than or equal to 0. If we do that, we get negative 8 is less than or equal to 0. This is true, right? Negative 8 is less than or equal to 0. So on our graph, we can include these points. All of these values of x make the statement true. So we're going to shade this in. So the last thing we need to check are the points on this side. We need to see if those are true. So if we select a value for x, let's say 6. 6 is right next to 5. Let's see if that makes this true. Let's come back here. Let's erase this. Set x equal to 6. Change it back here. So we're going to have negative 6 squared plus, and that's in parentheses, right? Do the negative after. 3 times 6 plus 10 is less than or equal to 0. If we do that, we get negative 8 again. Negative 8 is less than or equal to 0, which is true. Negative 8 is less than or equal to 0. So if we come back to our graph, all of the points on this side where x is greater than 5 are true. This is what our graph looks like of our inequality. So if we were to write that out, we would have this right here. We would say that x has to be, let's see, less than or equal to negative 2, right? Or x has to be greater than or equal to 5. That is just putting this graph into word form, right? Because we know this point is negative 2, and all of these values make it true. So anything less than negative 2 or equal to it makes the statement true, and anything greater than or equal to 5 also make the statement true. So try the problems that I put in your book. If you have questions, let me know. Definitely willing to help you guys. We can Skype or do something like that if you need. Let me know how it goes.